messed up. Okay, now we're going to be doing line graphs. So this data table here is really important. This is what we're going to be graphing. Okay, so you take a quick snapshot of that, and that's what we'll be using. Okay, so line graphs are different than bar graphs. They show trends. Okay, they show trends. So here we go. There's variables, and we have an independent variable and a dependent variable, which we should know by now. On the y-axis, always the dependent. On the x-axis, always the independent, what you're changing. Okay? They show trends, and we're going to go over this no dot the dot stuff versus dot the dot. Okay? So this is where we get into portrait or landscape. So if the x values are greater than the y values, it's in landscape, okay? So remember, landscape is like this, with the holes up top. And we do that so if the x is larger, it gives us more room to write it. If the y is smaller, we have less room. Now if the y is larger, we put the paper like this with the holes over on the right so that we have more room to write the y. So whatever one is a larger number, that's the way we're going to orientate it, have it anyway, you know what I mean. Have it situated so that we can actually have the most space to put the bigger numbers in. So when we go back to our data and we look at it, okay, the question is what is the independent variable and what is the dependent variable? So it says that certain temperatures will have certain volumes. So temperature is the independent, volume is the dependent. Okay, and that would be a little bit easier if we were like, I'm trying to think of something real quick, like trying to determine how much water, like if I add more water to a plant, will it make it grow more? And so you put 1 cup of water, 2 cups of water, 3 cups of water, and then we measure from there. How much water would be your independent, and the growth would be your dependent because it depends on the water. At least that's what we're checking, okay? But something like that. And there's all kind of better examples than that, okay? So first up, our independent and our dependent. Our independent is 360. Our dependent is 256. So our independent variable, which always goes on the x-axis, is going to be our longest side. So our graph will go like this. Okay. Now once again, we're going to draw the axes the same way we did with the bar graph. I like to go over 3 spaces, 3 or 4, but 3 is better for me. And I go up 3. Okay. And we're going to label them. So we're going to label them the same way it says here, okay? Temperature, independent. Do not short-handed. Don't put temp or something like that. Put the whole thing. Then over here is going to be our volume. Make sure we always put the units with it, okay? So now we have to do our scale. All right, and the scale is going to be pretty similar to how we did the other one, except if you remember on the x-axis it was a little different because we were doing bars. Okay, so I always like to look at my notes as I'm doing it. Obviously it didn't help last time when I messed up the one number. So I always like to do the y-axis first. I don't know why, I just do. So here's our y-axis. So our largest number on the y-axis is what? What is it now? 257. So I'm going to round it up a little bit. I'm going to go 260. You notice we always do this round up a little bit. All right. And so it's our largest number divided by the number of spaces, just like before. Then once we get a number, we round up. Okay? So 260 divided by 25. I forget how many spaces I had in the last one, but let's just say there's 25 spaces. There might have been like 28, depending on what kind of graph paper and where you put the axes will affect it. All right. So 260 divided by 25 is 10.4. Okay. Now, if we recall, this is centimeters cubed, and this is the number of blocks. I always like to write that. It helps me a little bit think about how things are supposed to be. Okay. So now we're going to go up from there, right? And that's a tough one. That's a tough one to pick, because depending on what number we pick, then we have to determine kind of where in the middle are we going to put it. I'm going to go up to 12. I think that would be okay, right? So halfway between a block would be like 6. I think we can do that. All right. Other teachers might not necessarily like to do it that way, but that's what I'm going to do. So 12, 24, 36, 48, hopefully don't mess this one up, 60, 72, 84, 96, 108, and I'm going to stop talking here for a second so I can think. That's 120, 132. You might need a little extra space here, so it might not hurt to put your axis over 1 or 2 more blocks. 146, 160, I think. No, yeah, 158. That's why you need to use pen or pencil. I messed up. I'm going to do it over again real quick. That's why you shouldn't probably pick 12s, folks. And another thing is don't use pen. I'm going to move over a couple more spaces. It's going to help me have room to write. Thinking about other things as I'm doing this. So what did we have over on the axis there? Volume. You're always good if you're 120, because 10 times 12 is 120. $180, that's good. See me slowing down. 240, what do we need to get up to? 252, 264. All right, maybe not the best scale to use, but it will work. All right, and it fit, so that's good. Now, down here, we're doing the temp in Kelvin. All right, so for our x-axis, we're going to do the same thing we just did. We're going to do the largest number, so for us it was 360, divided by the number of spaces. All right, number of spaces for me in the last one, if I had my paper still here, that'd be fantastic. I said there was 38 spaces, and I think I have a couple less this time. So, 38 spaces. So 360 divided by 38 would be 9.4 or 9.5. And I'm going to round up, so I'm going to make every one 10. All right? So that means it would be 10 Kelvin per block. Now that's a lot easier, folks, a lot easier. So I'm gonna do every single one, 10, 20, 30, 40, 50, 60, 70, 80. Can you imagine using the smaller blocks to do all this number stuff? I bought a bunch of graph paper that actually has the smaller ones. That's why we're using pencil also, folks. Okay, so there we are. Now we need to graph our data, right? We find it, we go like this, and we figure out where to put it. So our first one has 100 Kelvin, that's down here, and 71 for the volume. So that's gonna be right below 72, right below it. That's our first one. 210, up here, 200, and we're going up to 155. All right, so where's 155? Right below 156. Okay, and then we go 280 and 195. So here's 280, and 195 is going to be right between, or it's going to be a little bit above 192. Got to think about how big is that dot that you made. That really encompasses quite a few numbers, so that's why it's okay. If it's just a slight tiny bit off, that the area of that dot, the volume of that dot will take care of that. And then 360 and 257. Okay. So now we're going to do, it looks like a straight line, and we're going to do a line of best fit. All right? Sometimes it depends on the teacher. Good. So in some cases, we don't start at 0, 0. I think a lot of times we're in younger grades, like we have to start here at 0, 0, and we go from there. Okay, that's not necessarily the case. What we're going to do is we're going to try to look at all of our dots, and we're going to put our, it's easier if we have like a see-through ruler, but we're going to put the ruler so that some of the dots are above the line, some of the dots are below the line, some of the dots are right on the line. We're kind of looking for evenly spaced. So if a dot's that high above the line, maybe you have another dot that is that far below the line, okay? And it kind of evens out. So it's almost like an average. We call it a line of best fit. Okay, and there's mine. So that's not bad. It's not the greatest line I've ever drawn as far as line of best fit, but right on, pretty much right on, a little above, a little below, so that's looking pretty good. All right, and the last thing we need to do, remember, no grade zone up top, so we need to write graph 1, and we need to label what it is. So what are we going to label this thing? All right. So the way we tend to label line graphs is the y-axis versus the x-axis. Okay, so I do volume versus temperature. That's how I write it. Okay, volume versus temperature. Okay, if we look at our data table in this case doesn't